Hi, my name's Dan, and I teach quantum computing at Carnegie Mellon University for the last 5 years. I'm here with, Sleepy Dog Olaf, and we're here to talk to you a little bit about quantum computing. The main thing that I want to talk about today is what people mean by a speed up on quantum computers. It's not really a speed up. In fact, quantum computers don't compute faster than classical computers at all. They actually have a slower clock cycle. What they do, though, is they take the information, they take the data, and they raise it into a higher dimension. Okay? And then you have to wonder, what does raising a higher dimension of data give you? Well, imagine that you have a piece of paper. Okay? And let's say that you're an ant on that piece of paper. We're going to consider you a two-dimensional ant. And I want to get from point A to point B. If you wonder, I'm going to ask you now, what's the fastest way to get from point A to point B? And think about that. What's the most direct way? Most people are going to say that the most direct line is actually a line. It's a complete line this way, right? And that's the fastest way. It's the shortest distance, no worries. However, I'm a 3D person. The 2D ant can't perceive me as a 3D person. They can see a projection of me into two dimensions, but they can't really understand what happens in the third dimension. But as a 3D person, I can take this paper and I can fold it. And I can fold those 2 points such that they meet. And now the ant can just take one step from one point to the next. The ant has no idea what the contour of this paper is in the third dimension because it can't perceive the third dimension. However, it's now essentially done the same distance of movement, the same movement in less distance. Essentially, to the ant, this is teleportation. It's just blipped away to the other side of the paper. And so what this means, right, is that higher dimensionality allows teleportation in lower dimensionality. 2 dimensions allows teleportation in 1 dimension. 3 dimensions allows teleportations in 1 and 2D. 4 dimensions allows teleportations in 1, 2, and 3, and so on and so on. It's turtles all the way up. And this is the trick that quantum computers use. Quantum algorithms are taking data, raising them into a higher dimensional space, rearranging the contours of that data, and then jumping from your initial point to the next point in a smaller distance. Now, the issue, of course, is that quantum computers are using qubits, which collapse in state when you measure them out. This is the equivalent of going from a super high dimensional piece of information down to a single one-dimensional piece of information. And this is a problem because the answer is actually generally stuck up in a shape or in a contour of the data that is really, really high dimensionality. And so when you read it out or you sample it out, you're getting a single one-dimensional projection. And how you actually understand the answer is a conversation for a later talk, right? But the main key concept I want to get across here is that quantum computers don't necessarily compute faster. They tend to compute way slower than classical computers. They find more efficient paths. They use completely different algorithms to have the same inputs and have the same outputs as classical algorithms. All right, that's it for today. Have a good one.